Hello again, this is Mrs. Michek, and we are going to be doing some enthalpy calculations. So our first problem says, how much heat is released when 3.7 moles of gaseous methanol condenses to a liquid? So the reason that I have this covered up is because a lot of times you will have to look up the delta H that you are going to use. So I went ahead and looked up the delta H, but I wanted to talk about what I was looking for when I looked up that delta H. So what we have here is it says our gaseous methanol condenses to a liquid. So what's going on when a gas condenses to a liquid? Well, that's called condensation. Well, I can't look up condensation, or I can't look up delta H of condensation. If you remember from the last video, I can't look up delta H of condensation, but I can look up delta H of vaporization. So that's what I did. I looked up the delta H of vaporization for methanol, and when I looked up the delta H of vaporization, I made it negative. So the delta H of condensation was not there. I want to make a note of that. Okay. The delta H of vaporization was there, and I just made it negative to be the delta H of condensation. So the delta H of condensation is negative 35.2 kilojoules per mole. So now I can use that in order to figure out how much heat is actually released. So you might be kind of confused. You might be like, okay, well, what am I actually looking for here? What is heat? What measures heat? What are the units that measure heat? Okay, so the units that measure heat are kilojoules. So in this problem, that's what I'm looking for. I'm looking for kilojoules. So all of the problems that we do, we are going to have three basic factors: delta H, kilojoules, moles. You will be looking for one of them. You might, more than likely, you're not going to be looking for delta H because it's a constant. More than likely, you're going to be given delta H, just like we were here. You might be looking for kilojoules, as in this case. If it asks for heat or energy, that's your kilojoules. If it looks for moles, obviously we're looking for moles. If it asks for mass, remember that we can convert moles to mass, so you would first find moles and then convert to the mass. Okay. So in this case, we are looking for kilojoules, heat. So I'm going to set up my formula so that I have kilojoules equals. And I'm going to erase this real fast so that my problem is a little bit easier to work with. Alright, so I have delta H equals kilojoules over moles. And basically I'm just going to rearrange this so that I have kilojoules by itself. So I'm going to multiply both sides by moles. And now I have kilojoules equals moles times delta H. And now I have both of those things. Moles is here, delta H is here. I can plug in kilojoules is equal to 3.7 moles multiplied by my delta H, negative 35.2 kilojoules per mole. And look, moles cancel. I'm left with kilojoules. I've run out of room. I'm going to put my answer up here. Oops. negative 130.24. Kilojoules. And you might be like, well, why is it negative? Because the heat is released. The reaction, or the methanol, because it wasn't a chemical reaction, the methanol lost the heat. So we call it, or we say that it's negative. Okay, next problem. If you felt pretty confident with this one and you want to move on to the next one, that's totally fine. Check your answer at the end. Okay, next problem. How much heat, again, must be supplied to melt 7.6 grams of ethanol? I gave you the formula for ethanol. So again, in this one, I covered up our delta H that I was looking for. So we're looking for melting. If you remember from the last video, melting, we don't call it melting. Or if you look it up, it won't be melting. It'll be the delta H of fusion. Since it is melting, we didn't have to do the opposite or the negative or anything like that. I just looked up the delta H of fusion. Oops. So that's what I've got here. Delta H of fusion. I'm still on there. Yep. So the delta H of fusion is just that, 4.94 kilojoules per mole. But unfortunately, I can't go straight into my formula of delta H equals kilojoules per mole. I don't have moles. So I need to convert my 7.6 grams of ethanol to moles. So I'm actually going to do that on a separate whiteboard. So over on this side, I have C2H5OH is my formula for ethanol. C, got 2 carbons, hydrogen, don't forget this one over here. I've got 6, oxygen, I've got 1, molar mass of carbon is 12.01, molar mass of hydrogen, 1.008. And the molar mass of oxygen is 16. Multiply all of those out on your calculator. And then add them up. Now remember, we needed to convert, I believe it was 7.6, yes, 7.6 grams of ethanol to moles of ethanol, so that we can plug that into our formula. All right, so I'll do this down below. Oh, I'm all up in the way. So when I do that, I get 0.165 moles of ethanol, which we can then use that number to plug into our formula in this equation. So remember back from here, I'm looking for kilojoules. So I want to get kilojoules by itself. I'm going to make a note over here that my moles are equal to 0.165. All right, so I multiply both sides by kilojoules. And, oh, not by kilojoules. What am I doing? I don't have y'all in front of me to be like, no, you're doing stuff wrong. Multiply both sides by moles. So then I get kilojoules equals delta H times moles. Same as the last problem. So then my delta H is 4.94 kilojoules per mole, multiplied by my 0.165, I'm out of room here, moles. Moles cancel, I'm left with kilojoules. Kilojoules equals and my calculator died. .8151. So I'm going to go with 0.815 kilojoules. All right. And that's it for that problem. I've got one more. If you felt pretty good about that one, you got the right answer, and you want to do this one on your own, you can. Let me rewrite this real fast. What mass of methane? Notice this is methane, not methanol. First problem was methanol. This one, again, is methane. So what mass of methane must be burned in order to liberate 14,720 kilojoules of heat? All right. So, talking about burning, what delta H will we be using for burning? Well, burning, we're liberating heat. In that case, I looked up delta H of combustion. Alright, so the delta H of combustion for methane specifically is negative 891 kilojoules per mole. And this wants to know mass. So, this problem is a little bit different from the last one. In order to figure out the mass, I first have to solve for moles. So that's what I'm going to do. I'm going to set up my problem. Delta H equals kilojoules per mole. And then I'm going to solve for moles. In order to solve for moles, I can't have moles on the bottom. So I have to multiply both sides by moles. So I get moles times delta H equals kilojoules. Moles still isn't by itself though, so I'm going to divide both sides by delta H. And I get moles. So my formula is moles equals kilojoules divided by delta H. So now in order to get moles, I'm going to plug into this formula. So I have delta H and I have kilojoules. So kilojoules is 14,720 720. But before I actually write that all the way out, it says it's liberating that much heat. If it's liberating, that means it's releasing. I'm going to make that number negative. And then I'm going to divide it by its delta H of combustion. Now remember, delta H of combustion is always exothermic. That's why this is negative. Those kilojoules are going to cancel. I'll be left with moles on the bottom of the bottom, which equals moles. So moles are going to be negative 4.147 divided by 891. Negative, nope, I didn't do my negative on the other one. Positive 16.5 moles. Okay, but we weren't looking for moles. We're looking for the mass of methane. So I'm going to skip to another whiteboard again. Keep in mind our 16.5 moles of methane. And our last step is just going to be to convert that 16.5 moles of methanol, not methanol, methane, to grams. No, what am I doing? So I'm going to have grams on top, so my moles can cancel, but I need to know how many grams. So I need to find the molar mass of methane. 1 carbon, 4 hydrogens, 12.01 times 1.008. Add those together. And I get 16.042 grams. Units are over here, grams per mole. Remember that grams per mole applies right here. All right, so I'm going to get 16.5 multiplied by 16.042 over 1. 257.35 grams of CH4 methane should be your final answer. And that's all for enthalpy practice problems. I hope you enjoyed. Have a great day.